This is a short video on section 3-3, measures of position. We're only going to concentrate on percentiles in this section. This introduces z-scores, but we're going to see z-scores in great detail in chapter 6. So we're going to defer them until we get to chapter 6. So do not worry about z-scores for this section. Now, in terms of percentiles, many of you have come across percentiles either in your own lives or if you have kids. If you have a standardized test, they'll give back your score, and typically they'll show you a raw score and then a percentile. And what that percentile means is, out of every 100 people, how many did you do better than? If you're in the 72nd percentile, you did better than 72 out of every 100 people. If you're in the 37th percentile, you did better than 37 out of every 100 people. So what we're going to look at here is how you calculate that percentile value. And the percentile formula that our book shows you is the percentile is equal to a fraction, where the numerator is the number of values below the number. So basically, how many people did worse, plus 0.5. Then after you've added those two together, divide by the number of values. How many people took the test? When you have that fraction, multiply times 100 to convert it to a percentage, you have your percentile. Typically, the percentiles are shown in whole numbers. All right, we're going to walk through a simple example here, example 8. Now, before I do this, one thing to realize, percentiles are typically used on large data sets. Example 8 here is very unrealistic. You wouldn't want to do a percentile when 9 people took the test. Essentially what percentiles are doing is they're taking the data, and everybody who took the test, dividing the data up into 100 equal groups or buckets. Putting 9 people into 100 buckets, you have a lot of empty buckets. So generally, if you want to use percentiles, it's because you have more than 100 people. Ideally, probably more than 200 before percentiles really start to be meaningful numbers. Now, that being said, I am going to show you the mechanics of the calculation in example 8 with a small data set. Okay, so we take, again, the data that we had seen in examples 3, examples 4, with the 1, 3, 5, 5, 5, 7, and 9. And I built a somewhat incorrect frequency distribution. I left out numbers just for simplicity here, so it's not supposed to represent a legitimate frequency distribution, but it bears some things in common with it. So each row is a data point. We look at the frequency that matches up with this. So we had a single 1, 1, 3, 1, 7, 1, 9, and we had the 3 5s. Now what I've also added here is a cumulative frequency column. Keep in mind this is going to work exactly the same as we did in chapter 2. First class, the cumulative frequency is just frequency. Second class, it's the sum of the first two classes frequencies. Third cumulative frequency, sum of the first 3 classes frequencies. Fourth, sum of the first 4. Last one, sum of all of them. Okay, with that in mind, to calculate the percentile, we're going to use this formula here. Number of values below plus 0.5 divided by number of values times 100%. So if we look at the answer document now, for the person who scored a 1, nobody did worse than they did. So we would take the 0, nobody did worse than them, plus 0.5 is 0.5, divided by the number of values, which is how many people took the test. In this case, 7 people took the test. So we have 0.5 divided by 7 times 100%. Grab my calculator here. 0.5 divided by 7 times 100 is 7.14. So that's the 7th percentile. Now, for the person who scored a 3, one person did worse than they did, the person who scored a 1. So in this case, 1 plus 0.5 is 1.5 divided by 7, still 7, times 100. So the 0.5, the 7, and the 100 are going to stay constant for each of these rows. The only number that's going to change is this, how many people did worse. So the 1.5 divided by 7 times 100 is 21.4. So that's the 21st percentile. Now we get to the 3 people who scored a 5. 2 people did worse. The 1 and the 3. So In this case, 2 plus 0.5 is 2.5 divided by 7 times 100. If I use my calculator properly, 1 times 100 is 35.71. So rounding up, that's the 36th percentile. Now here's the one that sometimes throws people. When we look at the person who scored a 7, we want to see how many people did worse. Sometimes people want to look at this and say, well, 1, 3, and 5, 3 people did worse. No, we don't want to look at how many unique values there were. We want to look at how many people did worse. So we had one person score a 1, 1 and a 3, and 3 people scored a 5. So there's 5 people that did worse. So this number below is 5. So 5 plus 0.5 divided by 7 times 100 is 78.57. So that's the 79th percentile. And then finally, the person who scored a 9, 6 people did worse than they did. All 6 the other people. So in this case, 6 plus 0.5 is 6.5 divided by 7 times 100 is 92.85. So they're in the 93rd percentile. And right here you see one of the reasons why percentiles are not great with small data sets. The highest scoring person on this exam, apologize for my clock going off there, we'll wait till it finishes. The highest scoring person was only in the 93rd percentile. It's impossible for that person to get higher because the data set is so small. There is nobody in the 99th percentile in this case. So this is the mechanics for calculating a percentile.